As I always say that first you have to save your project using the save control plus S or save project icon here. Okay, so after that, your project home will be created. Okay, so make this a habit of first saving your project. Okay, so this, because this not only helps you in saving your data but will also save a lot of time for you while browsing through multiple folders. Okay, folders and subfolders. Okay, so your project home is created. So in this project home I have provided you, so make a project home of the folder where all this data is present of deal 4. Okay, so first we are going to use these two TIFF files. This is 80 underscore east and 80 underscore west. Okay, so let's select them and drag them on our interface. Okay, so here you must be observing that there is slight overlapping of rasters. Okay, slight overlapping of rasters, right? And these are two different rasters. So let's merge them together and let's make a single raster. Alright, so before that, before we go into the merging part, let's have some overview of what are these rasters and some information. Okay, so if you want to have any information about any of your data, for that you have to go to properties by right clicking on a particular layer. Okay, so go to properties, okay, and go to information here. Okay, so this is your width. Okay, width of your raster, right? And this is your height. So this is your columns and rows, right? Pixels, we have seen the pixels, right? So this is your rows, columns and rows, right? The data type is integer. So this raster data is made up of integers, all right? And this is 16 bit. So 16 bit means that the raster will have negative as well as positive values. Okay, right. So 16 is the data structure, right? There's the character of the data will be, sorry, the length of the data will be 16. So there are 16 numbers. Okay, right. So okay, let's see the coordinate reference system, right? We have geographic coordinates units here. Yes. So please keep in mind about this data type because we are going to use this today. Okay. So this is integer 16 and 16-bit signed integer. Okay. Signed integer means that your data will have negative and positive values. If it is unsigned, that means you have values integers starting from 0. It will not capture or contain negative values. Okay, and click on OK after this. Okay, right. Next, let's start with merging. Okay, merging these two rasters. Right, for that, go to raster. Today we are just going to use this tool. Okay, raster menu here. And for this, you go to miscellaneous. Okay, in miscellaneous, you will find merge option. So we'll go to merge. Right. So you will get this window. You have to provide input layers, right? Input layers, that means it's, of course, we are going to merge layers more than one. Okay. And it can be n number of layers that you want to merge. If you have more layers, then click on select all. Otherwise, you can just check these boxes. So once you are done, go back. Okay, and if you want your raster data to be in 3 bands, right? Because this data is only single band, so there is no point of making it into 3 bands. Okay, it won't help you in any way, right? So next is our output data type. Okay, so output data type, as we saw, this was integer 16. This is your 16-bit, but this is unsigned. But our data is integer 16-bit. Okay, so float is used for your decimal numbers. Okay, decimal numbers. But because it has given us that the data type is 16, the raster contains integers, not decimals, so we will go with integer 16. Okay, so click here. All options options we will keep as default, and once you are done, you can either merge, you can keep save this temporary file, okay, and you can also save this file to a folder to wherever you want to save it. If you need it for future use, you should save it here, okay. Okay, otherwise you can later you can also make it permanent, no problem. You can do it here as well. Okay, then click on run. Okay, so I think we got our merged raster. Okay, see, we got our merged raster, right? Okay, so now when we have got our merged raster, so next is to reproject this raster. As this area is Arunachal Pradesh, eastern part of India, okay, not one of the northeastern states, right? And so this actually falls in 46 north zone. Now we want to reproject our layer, okay? Because when you have to perform some analysis, then your coordinates, if it is in meters, then it is better than degrees measurements, okay. So for that you go to projections, okay. So for in projection you will find this warp or reproject. Now you are reprojecting your layer. So warping or reprojecting your layer will actually assign this layer the uh, the projection that you are going to use now, okay, because we are going to use 46 north, and you will see that the reprojected layer will have the same yours sorry the same projection that you are assigning right now, but others layer that that we dragged and dropped here, it actually acquires on the fly projection. On the fly projection means the projection that our project has. Okay, so our project has this EPSG 4326. So right now the individual projection of layer doesn't matter. Okay, so whatever layer you will project here will be assigned 4326. Okay, this WGS 84. Now, if you want to change the projection permanently of your data, then you have to var or reproject it. Okay, so click here, and we want to reproject our merged layer. Okay, so what is our source? Our source is 46, 4326, 84. Okay, and our target is, as I said, 46 north. Alright, you can resample the pixels. Okay, nearest neighbor will give you, so it is in simple in calculation. Okay, so with nearest neighbor, you actually only consider one pixel and the closest one to the interpolated point. Okay, this require actually very less time, so that's why it's a default here. If you want to see your reprojected layer quite look smoother, then you should go for bilinear or higher power of polynomial equations. Okay, so these are different methods of interpolation, right? So you go to cubic, okay, or I mean you can also keep it nearest neighbor, because it is it is simple in calculations. Okay, and here if you will come down, then you will see this code. Okay, so this is your GDAL. As I said, it's an open library for for analyzing your raster. So whenever you're analyzing your raster, you will see this GDAL. Okay, so after this you can click on run. Okay, so our layer is reprojected. So if you check its properties, if you check its see, the extent is changed. Okay, so before here it was your degrees decimals. Okay, and see here your EPSG is changed, right? So here it says the processing warp reproject tool should be used to reproject a raster source and permanently change the data source CRS. So now if you are going to save this layer, then this layer will have the your reprojected 46 north projection. Okay, so this is the benefit of reprojecting our layer. For that, you go here, select CRS option. Okay, click here because you don't have CRS defined anything. then you go to predefined CRS. Okay, so here just type, if you are not getting the list, right, just type 46 north, and most probably you will get this. To your open layer styling panel, okay, and find transparency here. Okay, second option, transparency. So here you don't have no data value, you have not defined it. Okay, so just type 0. See, everything is gone. Okay, so that means these values are 0, and you are adding transparency to all the pixels that have 0 value. Let's go to our terrain analysis, where our first thing is to create hill shape. Raster, go to analysis part, right, and here you will find hill shape. Okay, hill shape, right. So before we process this thing, so hill shade is basically a technique for visualizing terrain, okay, determined by the light source, okay, and the light source, and using the altitude. This is your angular distance of this source of light, okay, and this is your distance in the horizon. So this black ellipse, the external black ellipse is your horizon, right? So imagine that your object, how far your object is from horizon, and what angle does it make from the source of light. So this technique is based on that. Okay, so you create a hill shape, right? So it is actually a qualitative method. Okay, so for visualizing topography, and does not give absolute elevation value. Okay, so its values actually ranges between 0 to 255, where your 0 represent the shadow areas, okay, and 255 represent the brightest regions. Okay, and so there are two options. There is traditional that we learned yesterday, and we will also perform it today, and there is multi-directional. So in traditional method, there is one source. Okay, so there is source from just one direction, and which uses altitude and azimuth properties. Okay, but in multi-directional, there are 6 different directions. Okay, and it also enhances visualization. But it is helpful when you have low relief regions. Okay, but not in the Himalayas or in the high relief areas. Now let's come back here and process it. I hope this azimuth and this altitude is clear. Okay, you know z vector is your vertical exaggeration, and your scale is ratio of vertical units to horizontal. Okay, okay, so here you must be saying that use Zevenbergen Horn formula instead of Horn's one. So the difference is that this formula or this technique was developed for smoother landscapes, okay, where you have low relief. So if you are working in low relief like plateau region, then you can check this box. But for this horn method, it is better for rougher terrains, okay. And you can also combine your shadings. And if you want to create multi-directional shading, the one we discussed in our theoretical part, you should check here, okay. You should check this box. So right now I will go with the default things, okay, and I'm going to use this reprojective layer. All right, okay, so again this is your Python code. You can use this code directly in your Python console. Okay, and after that click on run. Okay, so your hill shade is generated. Okay, next we will create our slope map. Okay, again for that you have to go to raster, click on analysis, and then click on slope. Okay, and yes, so we are going to use our reprojected layer for creating slope. Band number, of course, we just have one, right? This is your scale. You don't want it to be exaggerated, so just keep it one, right? Now if you want your slope as percentage instead of degrees, Okay, by default it will give us slope values in degrees. You can check this box. Again, if you want to use this formula, okay, you can check this box when you are working on low relief regions. Okay, right? Let's keep everything default and then click on run. Close it. See, you got your slope map. Okay, now if you want to see the hill shade effect as well, you know how, like, we can blend them together. Okay, yes, let's try to style it now. Okay, and for that, you have to click on open the layer styling panel. Okay, on this icon, right? And after this you will get this window on the right hand side, and go to the first icon here. There's this brush like icon which says symbology. Okay, and make sure your slope layer is selected in the first option. Okay, or any layer that you are editing. This is your single band. Let's give it some pseudo colors. Okay, see, right? For the So in order to style your layer, right, first we have to examine what are the like how many values are there of particular attribute. Okay, so if you are talking about 0.34, so how many number of values are there for 0.34? Okay, so your histogram computation will help you in this. Okay, let's visualize our data. So you go to the third icon here, histogram. Okay, and let me enlarge this a bit, and you click on this compute histogram. Okay, so you see most of your values are between 0 and 60. So this is the frequency, that means the number of values, okay, of particular pixel. Pixel value is your slope values. Okay, because in this DEM, yesterday the DEM that we used, it had elevation values in pixel, but this DEM has have slope values. Okay, slope in degrees, right? So you see this histogram shows you the decrease in values after, like, after 50 or 60. Okay, so we don't need these values. Okay, because this is not going to help us in identifying our area of interest. Okay, so let's remove these values, because see, these values are very less, so they don't affect our data much. Okay, so we can remove these values. In the same way, if you'll see that there is peak here, right, between 0 to 4. Okay, between 0 to 4 degrees there is a peak, because see, most of this area must be between 0 to 4 degrees. This is your Brahmaputra plain. Okay, so that's why, right? So let's try removing the extra value. So go with the maximum. So click on this hand like icon. Okay, and after that make a click here. See, as soon as you click, you get a value. Your maximum value is changed here. Okay, and your the symbology is changed, the color distribution is changed. So anything greater than 50 will be categorized, right? So it will be greater than 50. All the values greater than 50 will get the highest color in the your color ramp. Okay, so if you want, you can also refine here as well. Okay, so let's keep it 1. Okay, we will start from 1 degrees to, I'll go with 40 degrees. Okay, so this is how I am going to distribute the classification. Now let's again go back to symbology. See, I'm making this map for slope only. Okay, your task will be to prepare such maps for aspect and relief and all these things. Okay, right? So just try to understand everything. So this is this is your interpolation. So interpolation is actually a method to estimate, or you construct new data points. As I said, whenever your data is missing, okay, between two pixels, then taking the average of those two pixels, you create a new data point in between and give it a particular value. Here we are going to use this linear interpolation. So if you want, you can change your color ramp, right? I'll go try with spectral, right? And let's invert the color ramp, right? See, all the plain, all the lesser areas, like the flatter areas, comparatively flatter areas, are in the blues, and all your hill slopes, the steeper hill slopes is in the red, which is the highest in our color rank. Okay. You can also change your mode of classification as we did yesterday. You can keep it quantile, okay, equal count, and you can also keep it equal interval, right? And again here you can change the number of classes. Okay, let's keep it 5. Okay, see, right? You can do that as well. Okay, so here we got our slope map. If you are satisfied with the color combinations and all these things, you can go and create your aspect map after that. Okay, so yes. So now let's create a aspect map. So aspect is so what exactly aspect is? That aspect helps you in identifying the direction. Okay. Let's go to our presentation. Yeah. So yeah. So aspect is actually your compass direction that the slope of terrain faces. Okay. So where in which direction your slope is facing. So an aspect of 0 means that the slope is facing north. Okay. 90 is for east facing, 180 is for south facing, and 270 is for west facing. Suppose there is a client who want to build in a particular land, he want to build his house in a hilly terrain. Okay, and where he have a condition that he wants to build his home in a perfectly north facing direction. Okay, or perfectly south facing direction, so that he can get the sunlight. Okay, so in that case your aspect map will help you, right? And so this is one example. We will discuss its more application after we create our aspect map. Okay. So for that, you go to raster. Okay. Again, we go to analysis. Click on aspect. Okay. So let's take reprojected DEM. Okay. For creating our aspect map. Okay, again, this gives you the azimuth. Okay, if you want your trigonometric angle as a result, you can click here here, right? And again, you can use this Zerenbergen Thorn formula instead of Horn. We will not use it because we are working on rough terrain. Okay, and let's keep everything as it is. Click on run. Click on close. See, this is your aspect map. Okay, again I'll just make it little bit colorful. See, you can see. Let's you know, you can manually change these values. Okay, and if I'll go with equal interval. Okay, because we have 4 primary directions. Okay, so first is our north, which will be your 0 degrees. Okay, second, let's keep it 90. Okay, double click here to change its value. Okay, so third will be your 180, right? And this, let's keep it 270. 270 is your west facing. So it is north, east, south and west directions. Okay, you can also create intervals, increase the classes. For northeast, if you want to go for 45 degrees, and you know, after this 135, like this, if you want to do that, you can do that as well by increasing the number of classes, and you can manually change it. Okay? Again, you can take the help of your histogram, right? So all the options are available here. Just you know, try hover your mouse and you will get the option, right? And you can compute your histogram, see, or you can see the slope values here, right? I'll go and recompute histogram. Okay, you can see the distribution of your slope values. All right. Okay, I hope you are fine with the slope. If you will zoom in, then you can see the color, right? So this color represents 112. Okay, so this is somewhere in your southeast direction. Okay, see this color. Otherwise, if you want, you can again change it to 0, 90. See, its colors are changing, and 180 and 270. Okay, for our convenience, for our understanding, you can see these colors are showing you the direction. Okay, direction of slope. Okay, in which the slope is facing. Okay, I hope this is clear. Let's start making our relief map. So relief map, as we all know, because we are using our raster data here, so we have to, as I already said, relief map is your the you get it when you subtract maximum elevation minus minimum elevation. Okay, so you need maximum elevation raster. So raster that contains only maximum elevations only and your minimum elevations only. Okay, so when you subtract your maximum elevation raster from minimum elevation rasters, then you get your relief map. Okay, so your raster, so what we are going to do, we will use focal statistics for that. Okay, focal statistics. So you type focal, F-O-C-A-L, focal statistics. Okay, focal statistics in your locator bar. Okay, so click here. Okay, there is some problem. Yes. Okay, right. So for this, we need our reprojected layer. This kernel is actually a window. Okay, we will use a square shaped window. So a window is created for cell, okay, for 3 by 3 cell or 2 by 2 cell, okay, right. So in 2 by 2 cell there are four, suppose there are 4 pixels, okay. So in 4 pixels, what it will do, it will identify which, for maximum elevation it will identify the maximum value, okay, and it will give it to the first pixel. Then this window will move in the right direction. Then again you will have 4 pixels and you will get the maximum value, and in the second pixel, maximum value will be assigned among the 4 values. Okay, so this is how your window shifts from left to right. Okay, right. Okay, let's keep everything default. Okay, see, there are these many outputs you can generate. You can generate mean value of elevation. You can generate minimum value of elevation in the same way I explained. You can generate maximum value of elevation. Okay, so we just need these three: mean, even we don't need mean value. Okay, if you don't need anything, just untick this box. Okay, we need minimum value, we need maximum value. Okay, we don't need value range as output. We don't need standard deviation of raster values. We don't need variance, because these are all your statistical parameters. Okay. You can also get the sum of the pixel. Okay. So you have 4 pixels. What QGIS will do, it will sum the pixel and give a value to one pixel. Okay. Then it will move ahead. Right. So it will do one by one. Right. So let me remove all these things. Right. If you will keep this while processing your focal statistics, it will take more time. Okay, so you just remove all the things that you don't want. So we just want minimum value and we just want maximum value. Okay, of elevation. Click on run. It will take some time. Okay, let's close this. So if you will see, so this is your maximum value, okay, from 0 to 7287, and this is your minimum value 0.0266886, okay. So after that, as I said, we have to create a relief map. So relief map is basically the maximum elevation value minus minimum elevation value, okay, between the rasters. Okay, so let's go to raster, click on raster calculator. So any type of calculation you want to perform with rasters, use raster calculator. Okay, this will be useful in your flood analysis as well. Okay, and here this is your maximum value, output layer. Okay, let's give it relief, relief map. All right, and if you see your output CRS is not correct, then you can change it here as well. Okay, so you want to, whether you want to add results to your project or not, you can mention it here as well. You can change your change the output format geotiff. Okay, right, you can use any of these. If you are working with other formats, right, then click on OK. Let's see if we will get our results. Yes, we got our results. Okay, let me close. If you want to see the difference between maximum and minimum raster, just zoom into a particular area and switch the above layer, switch it off, and see the difference. Okay, so this is your relief map. Let's close this. Now it is completely black. Now we have to give it some symbology. Okay, after that click on relief, single band pseudo color. Okay, you can see some different shades of maybe orange and red. Okay, and let's compute our histogram. Yes, see your relief, there is a difference in relief and elevation as we have discussed before. Okay, so your relief is maximum relief is 600, right? The most of the values is accumulated at this point. Okay, I hope this is clear. And yes, right? So if we compare this with our elevation raster, okay, if you compare this region have low relief, okay, low relief, but okay, sorry, okay, we have to color this as well. Let me apply colors. Yeah, now let's see. This has low relief, but you see this has high elevation. So one thing we can infer from here, that this can be some sort of plateau region. Okay, some sort of plateau region where you have low relief, but this plateau is located at some height. Okay, I hope you are understanding what I'm trying to say, right? So these are all your low relief, low relief regions. Okay, this red represents low relief and blue represents high relief. If you want to see more high relief regions, then you can go again here and see this blue represents your high relief regions. High relief regions means you have steeper slopes here. Okay, elevation changes quite steeply here. Okay, so this is what your relief map will look like. Okay, let's keep it 0. Let's keep it 500. Okay, okay, fine. Now, next is our how you can extract your raster. Okay, so for that, go to raster, extraction, and clip raster by extent or clip raster by mask layer. So this mask layer can be any vector layer. Okay, suppose if you have a watershed boundary, you can clip your raster using that watershed boundary. Okay, clip means to extract that exact area that is your area of interest. Okay, and go to clip raster by extent. You can try another different method. So I want to extract slope map. Okay, because we are going to convert the slope raster to vector polygons. Okay, so I'll take a smaller area because this again take a lot of time in processing. Okay, let me take a smaller area. I'm just dragging. Okay, I'm just making a rectangle here. Okay, what I did, I used this down arrow here and I opted for this option, draw on map canvas. Okay, draw on map canvas, and after that zoom in. If you want to extract this particular area, then click here and hold your left mouse button and drag. Okay, drag to the extent where you want to clip it, till where you want to clip it, right? Keep everything as default. We don't change anything here. Okay, then click on run. Perfect. Okay, so I think we got our clipped area. See, you got our clipped area, right? So this is your slope clipped area. Okay, now our next task is to convert it to vector. Okay, so for that you go to conversion. Okay, so everything is very straightforward. See, when you want to convert, so you will find your options in conversion. Okay, so you don't have to memorize everything. So just use the logic. Okay, so you want to polygonize it. Okay, you want to convert your raster to vector. So in case you want to share your your slope values in vector format, which you generated using your raster analysis, then you can polygonize it. Okay, polygonize. Okay, so you want use input layer as clipped one. Okay, clipped slope layer. Okay, so this dn is your pixel values. Okay, if you are using 8 connectedness, then it will acquire 8 pixels to connect and form a polygon. Okay, so you can use that as well if you want. Just check the difference. Actually, most of the things depend upon the results that you want. Okay, if you think your results are better using 8 connectedness, then you can go with that. So this is just a tick away. Okay, you can just tick here and use it, right? And now I will click on run. Okay, see, you got your vectors. Okay, so everything is, so all the values of slope is in its attribute table. Okay, so click here and go to this open attribute table. Okay, see, you extracted all the slope values. So this dn is your slope values. Okay, starting from 0 to and 65. Okay, so this is your FID. So FID is, as yesterday I said, it is your function identifiers. Okay, right. I hope this is clear till here. You can give it different colors in case you want to, you know how to style a vector. Okay. Again, you go to your graduated symbology, like the one we did yesterday for our contour polygons. Okay. You can use graduated. You can also use static, because there are like thousands of values. Don't use categorize, because each value will get one color. Okay. So in that case, you classify your values. You give it a range. Okay, and then click on classify. See, this way also you can create your slope maps. Okay, you can just adjust these values using the histogram. See, most of your values are accumulated here, right? So you don't need to go beyond this limit. Okay, so um, just remove the values. Okay, see, this is your histogram. You load your values here. Okay, and this mu is your mean of all the values, and this is your standard deviation. So this is your first order standard deviation. Okay, so most of your values are accumulated between this. If you want, you can change the, you can also capture these values. Okay, and your classes will be divided according to that. Okay, so I hope this is clear. Let's see how we can create our band composite image from this single band multiple images. Okay, so you can select any number of images you want. So these are all your black and white gray images. Okay, so let's see. For that, go to raster, go to miscellaneous. Okay, and then click on this build with virtual raster. Okay, you create a virtual raster. So here input layers will be all the layers that you want to create, that you want to use for creating band composite image. Okay, in band composite image, you will have 3 bands, red, green and blue. Okay, it will be a colorful image, you can say. Right. So if you want to change the resolution, let's keep it average. Now, don't forget to tick this box which says place each input file into a separate band. Okay. see the properties of this image. Okay, so you have to click it on the layers panel and check whether this is selected in the layer styling panel. Okay, so this is your multi-band color. See, till now we were discussing about single band pseudo color and hill shade. Okay, now you have multi-band color. Okay, so here you have red band, here you have green band, here you have blue band. Okay, so if you want to give it a false color composite, okay, we call it FCC, then you so your red is your band 3. See, so your green band is your band 2 and your blue band will work on, I think, band 1. Okay, see, you got your false color composite. Alright, that how can we create our own raster. Okay, see, to create raster, first of all, I'll discuss here only as ASC format. Okay, ASC grid format. Right. So let me go to the folder. Yes. So to create raster, you need a txt file. Okay. So open this txt file. In your txt file, you have to mention number of columns. Okay. See, I have created only 2 number of columns just for the reference. So these are all your values. Okay. So these are all the values you are giving to raster. Like first pixel will have 43 values, second pixel will have value of 2. I mean whatever value it can be. It can be elevation, it can be temperature, and it can be if you were talking about crops something. Okay. So if you want to give it some vegetation index, you can give that values as well. Okay. So this is actually a particular format of ASC data format. Okay, we discussed it on our raster analysis, raster yesterday, I guess. Yes. Okay, so in this particular format, what you have to do, you have to mention the number of columns, like number of columns your data will have. So this is your number of columns. Okay, this is your first column, this is your second column. In this way this data is written. Okay, so number of rows, so these are your number of rows. Okay, number of rows, right? And when you are typing these numbers, you have to give space, one space. Okay, and your how many like corners will X have. Okay, if your raster have like X corners and Y corners. Okay, you're giving here the extent. All right, your cell size, you have to provide the cell size. I have just keep it 30. And if you have any no data value, you should also mention that. Okay, in which your value won't be there. Okay, so when you have created such data, okay, or when you have such data and you want to create raster out of it, what you have to do, this is very simple now. You will go to add data. Okay, open data source, right? From here you select raster, right? Again browse and use this txt file. Okay, now our raster QGIS will understand that this txt file have particular format which is ASC format. Okay, if you want you can go through other formats as well. Okay, so there are grid formats and all these things, but I'll just explain with the ASC format. Okay, so now and it will understand, okay, it has some headers and it has some footers if you are providing footers, but headers are must. Okay, then it will recognize, okay, now you want to create raster with this txt file. Okay, so this txt file have all the information. So this is a kind of a database, okay, that you are providing it, right? So you can click on, you can also change the data, right? Because your data is our data is only integers. You can specify that, otherwise you can also go with default, no problem. Okay, then click on add, provide, yes, also provide the CRS. Okay, let's keep it WGS84, click on OK, click on close. Okay, see, we got our data which is ranging from 1 to 89. Okay, now let's zoom this to a layer.